Hi everyone, this is Mr. Edwards. Today we're going to do some remediation for Unit 7 on quadrilaterals. So our agenda for this remediation is we're going to review some essential vocabulary, and then I'll provide some direct instruction on 6 selected problems from the actual Unit 7 remediation assignment that cover main topics for quadrilaterals. After that, you should try to finish the rest of the remediation on your own, and you can use the key to check your work and ask questions if you still need help. All right, so let's talk about an overview of essential understandings and skills for our Unit 7 Quadrilaterals unit. We need to be able to analyze quadrilaterals using specific vocabulary like angle bisector and congruent, parallel, perpendicular. We're going to solve for sides and angles of quadrilaterals using both numeric and algebraic approaches. So that numeric just means there's no x's or y's really. It's just numbers. And then algebraic approaches is where we actually write a math algebra equation and solve it. And then we're going to use properties and coordinate methods. So that means on a graph to classify quadrilaterals. And that means what shape is this? And can you prove it? All right, so let's look at some key terms, some vocabulary. Diagonals are the segments that join opposite angles or vertices. So it's these segments right here that join opposite angles. To bisect means to cut or divide into two congruent halves. So we have an angle bisector. That's a segment or ray that cuts an angle completely in half, and it makes both angles equal. And then we have a segment bisector, and that's a line that cuts a segment perfectly in half, and that makes these two halves equal. We have parallel, and those are lines that are in the same direction, same slope. So these are examples of parallel lines, and these are non-examples. These lines are not quite parallel. Perpendicular means two lines that meet at a 90-degree angle. So these diagonals for this kite are perpendicular. They make a 90-degree angle. However, you'll notice that for this sort of generic random quadrilateral, this angle right here is not quite 90 degrees. That's an obtuse angle. And then this angle right here is an acute angle. Okay, so those are not perpendicular. Supplementary, those are angles that add to 180 degrees. So for instance, with these two parallel lines, angle 3 and angle 6 are supplementary. We have vertical angles. Those are angles that are across from each other where two lines intersect. So 2 and 4 are vertical angles. 1 and 3 are vertical angles, and those are congruent. Linear pair, those are angles that form a line and are adjacent or next to each other. So these two angles are called a linear pair, and they always add to 180. Opposite angles are angles that don't share a quadrilateral side. Some people think of them as angles that are across from each other, and that would be a fine way to think about it. And then we have consecutive angles. Those are interior angles that do share a quadrilateral side. So you can think of it as angles that are right next to each other. All right, so let's actually get into some real problems from our remediation assignment. These are pictures of all of the quadrilaterals from this unit, and they do have their diagonals in there, and that's going to be really helpful because we're going to actually look at some problems from the actual remediation assignment now. The ones that are circled here, and there are multiple pages, I'm going to do 6 problems for us, and I'm going to walk through how to sort of think about these and what I would suggest you should do to actually show your work for all these. So for numbers 1 through 3, we want to determine which of the following quadrilaterals has the given property. We want to circle all correct answers. Now, some people think that they just have to memorize all of these facts about all these quadrilaterals, and I find that that's really difficult. So I actually suggest that we carefully read the problem. We underline what given information we have, what we want to find. We want diagonals that are perpendicular. Or in other words, they meet at a 90-degree angle, okay? So we have all these shapes, and I would suggest that you draw or look at a picture of all of these shapes. And we want to ask ourselves, which one of those shapes have diagonals that are perpendicular, okay? Let's look at the parallelogram. Well, the parallelogram, let's see, right here, just kind of by inspection, you can tell this angle is acute. These diagonals do not meet at a 90-degree angle. We want to look at the middle, and this is not a 90-degree angle. So a parallelogram is a no-go. All right, so a rhombus. Let's look at a rhombus. So we have a rhombus here, and if you look, these diagonals, they very clearly make this nice 90-degree angle. It's this perfect sort of cross or plus sign in the middle. So that is a yes, okay? So a rhombus does count. A rhombus does have diagonals that are perpendicular. A rectangle, A rectangle, no, absolutely not. That is an acute angle, not diagonals that are perpendicular. A square, absolutely. You can tell that that's a 90-degree angle. You might have to sort of like tilt your head if you want to really sort of verify, but that is a 90-degree angle. Square has pretty much all of the properties that you would ever hope a quadrilateral would have. A kite. A kite, this is a 90-degree angle, yes, and just kind of visually inspect that. You can totally tell. And this also means it's really good, folks, to be able to draw a very good representation of your shape. So you might want to practice that a few times. So a kite does an isosceles trapezoid. An isosceles trapezoid. Just by inspection, you can tell, no, this does not have a 90-degree angle. These diagonals are not perpendicular, okay? We also have a trapezoid or a generic trapezoid. That just means any trapezoid that doesn't have these congruent legs, okay? So you want to make sure that you understand the difference. A generic trapezoid or just a trapezoid, its legs, so the sides that join the opposite parallel bases, are not necessarily congruent, but an isosceles trapezoid, those those legs are congruent. They are absolutely equal. Okay, so that's that'll help you sort of reason through number 2 and 3 as well. So you want to look at the vocabulary and look at your pictures. So then we have, based on the markings, decide whether each figure must be a parallelogram, and we want to justify our answers. And so you do want to memorize a few key facts about parallelograms, and that's actually in your remediation. So these are properties of parallelograms right here. You want to have all these memorized about what is a parallelogram. And the first one here, both pairs of opposite sides need to be parallel. And you know that they're parallel if they have this little triangle that points in the same direction. So these sides are parallel, and then your left and right sides are parallel. That's just the definition of a parallelogram. And for that reason, we're reasoning by definition here. By definition, this shape is a parallelogram, absolutely. And our reasoning for that is, I'm going to just sort of type this in here. Our reasoning for that is because both pairs of opposite sides are parallel. Okay, so you want to just reason by definition, and so that reasoning will help you complete the next 5. If it does not meet the definition of a parallelogram, you would say no, and you could say that there's not enough information. All right, let's move on to number 5. We're going to determine the values of x and y for which A, B, C, D is a parallelogram. So I'm going to zoom in on this, and then we're going to figure out how do we even approach this problem. All right, so I'm going to scroll down here. So in any picture where there is a shape with algebra attached to it, you want to really ask yourself, what properties of this shape tells me that two things are equal, or do multiple shapes add up to something greater? And you're going to need to be able to visually recognize this. So let's just look at 2 angles. So we have our bottom left angle and our top left angle. And a fact about parallelograms is that these 2 angles are consecutive, and that means that they add to 180. And just visually, we have an obtuse angle and an acute angle. So those angles do add to 180. So how do we actually write this out? We're going to write that 4x plus our obtuse angle, which is 3x minus 2, equals 180. Now, it would be a misconception to write that 4x equals 3x minus 2, okay? Just visually, these angles are not equal. They don't look like they're the same size, so don't set them equal to each other. Okay, so we do have some like terms. So I'm going to combine those, and we'll get 7x minus 2 equals 180. We'll add 2 to both sides to get 7x equals 182. And then we definitely want to divide both sides by 7, and 182 divided by 7 is 26. All right. So very good. We have x. All right. And then we notice that we do have 2 angles that are equal. X plus y is equal to 4x because those are opposite angles in a parallelogram, and that is a property of parallelograms. And that 26, we actually can substitute that for x. So we actually have 26 plus y. Okay, so that 26 plus y is equal to our 4x, and our 4x is actually 4 times our 26 because that's x, and that is going to get us 104. Okay. So those two red angle expressions are equal to each other. And when two shapes are equal, we can set their math equal to each other. So 104 equals 26 plus y. And then we want to subtract both sides by 26. So 104 minus 26 is 78. All right. Fantastic. Okay, so this one was a little bit tricky because it had both an x and a y, and so that's why I wanted to just formally walk you all through that one. All right, so let's go ahead and move on. We're going to move on. We're going to move on to a numeric example. So that parallelogram example that we just did was an algebraic example, and now we want to try a numeric example. This is really a test of your eyes and your symmetry abilities. Can you just visually tell what is equal to what? So let's zoom in and we'll take a look at this one. So we have right off the bat, I really like to look at vertical angles first. I find that those are sometimes maybe the easiest for a good portion of students to recognize. Vertical angles are angles that are equal to each other and they are across from each other when two lines intersect. And then a lot of people like to go next to linear pairs. Linear pairs are like angles 2 and angle 3. And when we sort of draw it in like that, they appear to form a semicircle. And so these two angles add up to 180. So that the angle 3 is actually going to be 180 minus angle 2, which is 72. And so 180 minus 72 is going to get us 108. All right, very nice. Okay, so we have 108 not only right here for angle 3, but we also are going to have 108 on the other side of this vertical angle, okay? So what can we find out next? Well, we have a 40. We have a 40. And then for parallelograms, we want to travel across the transversal, and we have an alternate interior angle. We have an alternate interior angle, which means that right here is also 40. And just to visually, you can sort of just visually see that these two angles sort of have the same size. And so why are we even doing that? Because we want to find angle 4. And we'll notice that we have a triangle. And this triangle has interior angles, these three angles right here, that add up to 180, okay? So measure of angle 4 is going to be 180. So we're going to have 180 minus 40 minus 108. And that's going to be the measure of angle 4, okay? So we have 180 minus 40 minus 108, and that's going to get us 32. All right, fantastic. Okay, so we also need to find the measure of angle 41. We need to find the measure of angle 41. And let's see what we can do for this. Well, we do know that we have 72 right here. We also have this 47, which by the same reasoning of how we got that 40, this will be 47. And look at that, we have another triangle. We have another triangle for angle 1. So our angle 1 can also be found by, let's do 180 minus 47 minus 72. All right, and that'll get us the measure of angle 1, and that'll be it for this problem. So we have 180 minus 47 minus 72. That's 61. All right, fantastic. Okay, so so this is definitely a test of your eyes and seeing if you can really see that symmetry. So I hope that that sort of broke it down for you all. All right, so we got just a few more. let's pop down here to instead of finding angles, angle degrees, we're now trying to find a segment length. So for this particular problem, we have a rhombus RHOM, and we want to find the length of RH. So we want to find this side if RO is 10 feet and HB is 6 feet. And what we always want to do, we want to mark up our problems, and we want to label. We want to label what is what. So we have RO is 10 feet. And what that really means is that we're gonna have RB is 5 feet, and BO is also going to be 5 feet. So I'm just going to sort of mark that up. And the reason we're able to break it up like this is because rhombuses, they have diagonals that are bisected. So these two sides are absolutely equal. Okay. And HB is 6 feet. So I'll go ahead and label HB as 6 feet. Okay, all right. And now we actually we want to ask ourselves, how do we find a side of this triangle? So a rhombus has diagonals that are perpendicular, and what that means is we actually have a right triangle. We have a right triangle. Okay, we have a right triangle, and we want to find the third side of a right triangle. Okay, so we're going to recall. We find the third side of a right triangle with the, here we go, Pythagorean theorem. Okay, big idea. We have used that so many times in geometry, and it does require some recognition. So you're going to have to recall that. All right, so we have so we want to do a squared plus b squared equals c squared. So we'll have 5 squared plus 6 squared equals x squared. Okay, so we'll have 25 plus 36 equals x squared. All right, and that'll get us 61 equals x squared. And when we have just x squared, we want to take the square root of both sides. So x is going to be the square root of 61. Okay. Or we could have a decimal approximation. The square root of 61, that's approximately 7.8. Okay, so let's go ahead and put that as our answer. So we'll have the square root of 61, or 7.8. And then we really want to check for reasonableness, because if we get an answer that didn't make any sense, we don't want to put that. And if we have 5 and 6, and then x is the hypotenuse, which means that it has to be longer than any of our 5 and 6 sides, 7.8, just visually, that makes a lot of sense. It feels like that should be the answer. If you got an answer that was like 100 or 4, those would not be reasonable. So you want to check for reasonableness. That is a metacognitive strategy. Ask yourself, does this look right? Does this feel right? All right. So that will cover to find sides using the Pythagorean theorem, and that's when you have a right triangle. All right, so let's move on to the back page. So we just have one more problem. We're going to do a graphing or coordinate problem. So in this problem, we have some quadrilateral A, B, C, D, and it has these vertices. We want to find the lengths and slopes of those diagonals, okay? And we almost always find lengths with the Pythagorean theorem. And we find slopes by counting our rise over run. So I'm going to go ahead and plot these points, and I'm going to label. So -2, 3, -2, 3. I'm going to put that down and label that A. So I'll label that A. B is 2, 4. C is 3, 0. And D is -1, -1. All right, and then we want to connect these. We want to connect the dots. And just kind of visually, so we want to classify A, B, C, D. That means we want to say, what shape is this? Like, is this a rectangle? Is it a parallelogram? And to classify, we need to use the most specific name as possible. So, for instance, we can't just say, oh, it's a quadrilateral, some kind of four-sided shape. We have to be more specific. And so, just kind of right off the bat, this just looks like a square. But we have to prove that. How do we prove that something is a square? We can prove that the lengths of their diagonals are congruent. We also can verify that the slopes of the diagonals are perpendicular. Okay, so that will prove that something is a square for sure. All right, so the length of AC. How do we find the length of something? Well, we can we have to use the Pythagorean theorem. We have to use the Pythagorean theorem to find the length of this diagonal right here. Okay, and how do we actually do that? We want to count down 1, down 2, down 3, and we want to count over 1, over 2, over 3, over 4, over 5. So that's over 5. So this shape right here is now a right triangle. The shape here is a right triangle. And we want to find the length of that diagonal. Okay, so we want to solve this. That's going to be 3 squared plus 5 squared equals x squared. All right, and then we'll have 9 plus 25, which is 34, equals x squared. So that means our length is going to be the square root of 34. All right, so we're hoping that DB will be the same exact length, okay? And this will be. So this will be. So we if we go from D to B, we'll go up 5 over 3. So this will be 5 squared plus 3 squared equals x squared. And this actually will also get us the square root of 34. All right, so then we want to find the slope of AC, and we actually already found the slope by doing the Pythagorean theorem. That's how powerful the Pythagorean theorem is. So we went down 3 over 5, down 3 over 5. So that slope down 3 over 5. dB, however, is up 5 over 3. So that's positive 5 over 3. And you'll notice that these two slopes, they are what's called opposite reciprocal slopes. Okay, opposite reciprocal means that we have one that's negative and one slope that's positive, and reciprocal means that the fractions are flipped versions of each other. So opposite reciprocal slopes mean these diagonals are perpendicular. All right, and all of that, because the two diagonals had equal lengths and opposite reciprocal slopes for the diagonals, the classification for the shape is proven to be a square, even though visually we sort of could tell that, but we can prove that more formally by seeing if the lengths and slopes of our diagonals are both congruent and opposite reciprocals. All right, so this remediation, folks, it's a little beefy because I wanted to explain sort of the main big concepts, and this was a lot. So go ahead and take what we went over and see if you can complete the rest of this remediation, okay? And let us know if you need any help or have any questions. All right, it was really fantastic being able to share with you all, and I hope you all have a great day.